Hello all, welcome in OSA IEEE Student Chapter IIT Bombay. We are celebrating International Day of Light on May of 16th, and this time OSA IEEE IIT Bombay brings a challenge called Break It Apart Challenge. In this challenge, basically, we will use an optical device and break it and explain the physics behind that. So basically we are choosing the optical devices which we are using in our daily lives, like an oximeter. So I hope nobody need to use this device, but during the pandemic we all are using this, and this device is the part of our daily life. So this device is working on a simple and a fundamental rule of optics and have so many optical components. I will explain this device in my today's break it apart challenge. So before explaining this thing, I want to show you some pictures of the this device, this oximeter device. So here you can see, this is our oximeter. When you will put it in finger and press this switch, it will show something like this. So it is showing this 98 is the SpO2, that means oxygen level in our hemoglobin, and pulse rate is 100. Okay, so this is the display. And what is there? So in the oximeter, basically there is a LED of red LED and as well as infrared LED. So when we are switching it on, you can see there is a one LED will blink here. You can see, yeah, you can see there is this one LED is blinking here. So as well as there is an infrared LED also, but infrared light we cannot able to see by our bare eyes. So basically it have two wavelengths LED, like 650 nanometer approximately, and other in NIR which is 950 nanometer approximately. The second one is the detector, which is here somewhere here on top, which will detect the light. So this is the part, these two parts. And third is the display. So basically here is the display and these are the processors. I will explain the processors work and the display. So this display is a simple display which we are using in our hand watch, some mobile phones, and so many digital devices. Okay, thermometers also. Okay, so in next I will explain the on which principle this device is working. So this device is working on a simple principle called Beers-Lambert law. So this device is working on this law. So what this law says? This law says if you have any light source and light is passing from here and you have a sample, okay, then absorbed light in the sample is equal to epsilon Cl, where epsilon is the molar absorption coefficient, C is the molar concentration, and L is the optical path, means whatever path is traveling by light in the sample. Okay, so in our case, what is the sample? You can see we are putting the finger. So this finger is the sample and light is passing from bottom and detecting somewhere here. Okay, so in this basic principle, our oximeter is working. So now I can explain what happened in oximeter. Okay, so here you can see this picture. This is a hemoglobin picture. Hemoglobin, in schematic of the hemoglobin, basically I took some from somewhere in biological science website. Reference is this. So this is hemoglobin. So this hemoglobin have property to bond the oxygen molecules. So this hemoglobin, when it start bonding with oxygen, then this called deoxyhemoglobin, and otherwise it is called deoxyhemoglobin. So in our blood, which is flowing in our arteries, have deoxyhemoglobin as well as oxyhemoglobin. So if this is called HbO2, if two oxygen molecules will bond with one hemoglobin, it is called HbO4. Similarly, HbO, that means one hemoglobin can bind 4 oxygen molecules. Okay, so if you are in this situation or in this situation, then you have to no worry. Now, what is the deoxyhemoglobin and what is the basically oxyhemoglobin, and how this device is measuring these things? So you can see there is a graph which is the absorption curve of the red one is the oxyhemoglobin, red one is for oxyhemoglobin, and blue one is for deoxyhemoglobin. Okay, so you can see absorptions of the red light, around 700 nanometer, which is red light. Okay, absorbance of red light for oxyhemoglobin is very less, and absorbance for in infrared light for oxyhemoglobin is high. That means red light is passing for oxyhemoglobin. Red light is passing for oxyhemoglobin, while infrared light will not pass. Okay, and for deoxyhemoglobin, you can see red light absorbance is high and infrared light absorbance is low. That means it is less passing in red region, and transmittance is high in infrared region. Then what happening when we are putting our finger here? Light, infrared light and red light is blinking from bottom, passing through our hemoglobin, and then calculating the transmittance of red light to the transmittance of infrared light. This transmittance will give us SpO2. Okay, this transmittance ratio will give us SpO2, which is the oxygen percentage in our bloods. Suppose out of 10 hemoglobins, 9.9 or suppose 100 in 100, 99 have with oxygen bonded, then this ratio will come 99%. Okay, so this is how our oximeter works. So now next is basically I can explain how this oximeter looks like and works. Okay, so this is simple oximeter. You can see I can remove the pads of this. So basically if I will remove the pads, then we can see very carefully this thing, and we can see also all the components of this. Okay, it's very difficult to remove the pads. Okay, I remove this pad, remove this pad also. Okay, so I'm removing the pads. I removed both the pads from here, so you can see now clearly here is the wires, here LED is there. Okay, here you can see LED is there. Okay, so other detector is here, detector is this one. Okay, detector is this one, you can see. And now I can show you the display of this one. So we'll break it, this part also, okay, so you can see here this one is the display, this one is basically processor, which is processing this digital calculating transmitted red light to the transmitted infrared light, And if I will show you the simple connections, it have two batteries basically, which we knows, and simple connections are there. You can see simply there is a connections are going there, and also you can see connections inside. Okay, so this is the basically simple structure. Only one LED, infrared and red, two LEDs. Okay, then one detector and one processor. So very simple device but very useful device. So thank you guys, hope you guys like this video. Thank you.